check your neck to see how you're moving. Once again, they're not necessarily looking for damage to the muscles. They're looking for nerve damage. They're looking to see if there's any nerve impingement. Sometimes with encephalitis or meningitis, you get a stiff neck. That stiff neck isn't because the muscles are stiff, it's because the signals coming through here have been compromised. And finally, the hypoglossal nerves. The hypoglossal nerve, essentially, well, actually you have two of them. This innervates the majority of all of those intrinsic tongue muscles, those little muscles at the base of your tongue that allows you to move your tongue in many different ways. There are numerous branches coming off of there. And this really allows you to move your tongue from side to side. Once again, contributes to swallowing, allows you to move your tongue up against your palate, which, believe it or not, is essential to being able to swallow. When you take a drink of water, when you take some food that you've been chewing, when you go to swallow, and you don't realize this until you pay attention, your tongue pushes up against the roof of your mouth, and it pushes the food to the back. And there's a wave of muscle action going on that takes the food that's in your mouth and pushes it back toward the pharynx. That kind of wraps up cranial nerves. Cool. We still have some more cranial nerve stuff because we're going to be looking at vision. I'm trying to get through this stuff today so we can take some time and look at the exam. So bear with me if I seem to be going at a fast pace. Eye movement, eye muscle pathways, the nuclear complex is kind of really obnoxious. There's a lot going on with the eye muscles and eye movement. We took a look the other day, beginning look, at the rectus muscles, okay? Lateral and medial rectus muscles, inferior and superior rectus muscles. Lateral rectus muscle moves your eye laterally, medial, medially, superior, oh, this is too simple, all right? Of course it's too simple. The reality for this is that this does not allow you to really look here, 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 or here. And you go, well, what if I move this one and that one? Well, it depends on which one you move first. Because you're not going to move them simultaneously. You move this one and that one, your eye kind of does this and that. Sure, you can kind of look over here, but it's not going to be the same thing. So in order to actually be able to look into all of these spaces, you have the oblique muscles. Here we have the inferior oblique. Here we have the superior. And remember, the superior oblique runs through the trochlea. That little piece of connective tissue is critically important because it allows, and this is showing it to you slight, you can't show it properly because if your eyeball was here, it's actually doing kind of like this. So it's on the top there, and it runs through and it comes straight back. So when this pulls, it causes the eye to do this, rotate a little. Does that make sense? You're following me with that. You kind of, can you visualize what's going on there? Maybe? Okay. Now, in this figure, it shows the lower pole and the upper pole of the body, of the eye. And it becomes important to understand the poles. Because if you understand the poles, you understand intorsion and extorsion. If you draw the pole right through the eye, with intorsion. The eye is going to rotate like this. Therefore, the upper pole is pointing medially. Are you with me? Do you see what I've just done? Now, with extortion, we pull this in. The upper pole points out laterally, and the lower pole points medially. If you will think about this, you know, as you look up to the upper left corner, your eyes are doing this. One of them is experiencing intorsion. One of them is experiencing extorsion. Yeah, you really have to think about what's going on. It's not totally, it's not real easy to think about. So look down to the right. Oh, this is what's going on. Oh, wait a minute. Down to the right, up to the left. I've kind of done the same thing. But up to the left, they're doing this. Down to the right, they're doing this. So they're going to work in unison with other eye muscles. Pretty much you can't use the superior oblique or the inferior entirely by themselves. Almost every motion that you make using your eyes is going to use multiple muscles. There's a nice table in your book on page 568. It ties a lot together. You have the muscles, the actions, and the innervation. That's about as beautiful simplicity as it gets. Abduction, horizontally towards the temple. Adduction, horizontally towards the nose. Intorsion, upper pole of the eye moves inward. Extorsion, upper pole of the eye moves outward. Yeah?
So if I'm looking up to the right, my right eye is being intorted?
Your right eye, the upper pole of the right eye is looking outward.
Extorted, okay.
It's being,
So,
yeah, it's being extorted.
okay, so my right eye is being extorted looking up
Yes.
to the right. Okay.
And really, I think if you were to sit down and write out a few little things, say, okay, I'm looking up to the right, I'm looking down to the right. What's the difference? And go through and think about it. Draw it out, showing the poles moving. I really think that helps a lot.
So looking up to the right, it's not just using the inferior oblique, it's also using the lateral rectus at the
Yes.
same time?
You know, so you're using the lateral rectus, and if you're actually looking up, you're using the superior rectus. So there's a lot involved. There is a lot involved with moving your eyes. So as, you know, once again, as you start to look laterally, we'll use the right eye looking laterally. The lateral rectus has to be involved. But when you look lateral and up, the lateral rectus has to be involved, the superior oblique has to be involved, and the superior rectus has to be involved. There's no way you can do that without all of it. This is amazing because it allows you to move your eyes in not like that, but in a complete, any of you know the comedian Marty Feldman from years ago? He could do that with his eyes. He had some weird brain disorder, and he could get his eyes to look out, both of them moving laterally. And he's the only person I've ever known that could do that.
Isn't he in, Young Frankenstein?
Yes, Igor.
Yeah.
So, or if you want to watch a really funny movie, it's in Italian, but with subtitles, Sex with a Smile. Completely hilarious. So, Marty Feldman. There we go. So there's a lot going on. All right. Maybe what I will attempt to do is put together a series of questions for you that says, if you look in this direction, what muscles are you using? And you could just, write this down, fill it out. All right. Well, eye movement is, as I said, pretty obnoxiously complicated. And part of the complication involved with this has to do with, in part, this whole oculomotor nuclear complex. This is the hardest part of the whole day. The dorsal nucleus, big red one there. Signals from the dorsal nucleus are ipsilateral to the inferior rectus muscles. Okay, well, that's not too bad. Intermediate nucleus. The signals are ipsilateral to the inferior obliques. Ventral nucleus. Ipsilateral to the medial rectus muscles. Edinger-Westphal. Edinger-Westphal is involved with the parasympathetic functions here, and it's bilateral. Now you remember that. We talked about that the other day. It's bilateral to the pupillary constrictors and the lens ciliary muscles. Now the lens ciliary muscles are interesting and important. It's kind of silly saying anything in the brain is important. Everything in the brain is important. So the pupillary constrictors means that your pupils will both constrict in the same way, or they'll both dilate in the same way. So constrictors will constrict. But then the lens ciliary muscles. These are involved with fattening or thinning your lens. That's going to change how light is focused onto your retina. And what that is going to do is change whether you're distant viewing or close viewing. In general, with parasympathetic, what's better? Your close view or your distance? Close. So when you're studying, you're sitting with your book close or your laptop, you're paying attention, you're reading, your eyes get tired? Sometimes they do. When you're just sitting looking at distant scenes, do your eyes get very tired? Not often. It's interesting. So you should think about that. You should say, which one of them is actually having muscle fatigue when you're reading up close? Okay. So anyway, Edinger-Westphal, bilateral. Levator palpebrae superior, caudal, central caudal nucleus, bilateral. Believe it or not, you have to really work at using